Hi, let's talk about Boyle's law. So gases, and with Boyle's law, we're focusing on pressure and volume. Here is the law, P1V1 equals P2V2. The ones indicate initial conditions and the twos indicate the final conditions. So a couple things you need to know about this. You can use any units for pressure and volume. You just need to be careful that you use the same units from the 1 to the 2, from the initial to the final. Now this is a little bit different. You've watched in other videos where temperature always has to be in Kelvin, that absolute zero base. But for pressure and volume, in this formula, it doesn't matter. Pressure could be ATM, millimeters of mercury, volume can be mils or liters, as long as you start with one unit and you end with the same unit. Start with mils, end with mils. Now notice, of the three basic gas formulas, Boyle's is the only one where the two variables are indirectly related. So as pressure increases, volume decreases. And equally true, as pressure decreases, volume increases. Now take note that when we're using Boyle's law, temperature is held constant. Okay, so temperature is held constant. Now, you've seen this. I'm going to show it to you again. This is how, really honestly, I do almost all of my chemistry, especially gas laws. I label everything that's given, and I'm going to walk through an example with you. Label everything that's given. There's something about taking what's on that page, writing it down, and giving it the variable that shows you where you begin and where you have to end, and you can figure out the path to get to that ending, to get to the answer. Second, we're going to identify what formula we're going to use. The variables that we use to label, they are always indicative of what formula you're going to use. Solve for the unknown. It's just really good practice to solve for the unknown and then plug in numbers. And then lastly, plug and chug. So I'm going to read a problem to you and show you, model for you, how I do my labeling. So it says a sample of CO2 with a pressure of 55 millimeters of mercury in a volume of 125 mils is compressed so that the new pressure of the gas is 78 millimeters of mercury. Okay, so right there, I see that we're going to change, it says new pressure. We're going to change the pressure. So I'm going to go ahead and write down those initial conditions. We had an initial pressure of 55. Notice we're using millimeters of mercury here for our pressure. And the initial volume is 125 mils. Now we're going to change that pressure. Notice that we're decreasing it. We're going to, we're increasing to 78 millimeters of mercury. And the question is, what is the final volume? Now, let's pause for just a second. You can predict what's going to happen to this volume because of this indirect relationship. So notice the pressure is going up. So what's going to happen to the volume? Pressure increases, so the volume is going to go down. So I would predict that this volume is going to be less than 125 mils. A really good visual on this is a car piston. Imagine you have your cylinder in the car, and then there's this piston that goes down. So as the piston goes down, the volume inside that cylinder is going to be less. But as we have this plunger go down, the volume gets smaller. You know what happens? The pressure, it increases. And then when we take that plunger up, increase the volume, there's less pressure. So the greater the pressure, when you decrease pressure, there's more volume. When you increase the pressure, pushing down, increasing that pressure, there's less volume. You could picture a syringe, same thing with the syringe. When you decrease the volume on that syringe, you can feel the pressure. Okay, so I see initial conditions for pressure and volume, final conditions for pressure and volume. That means that we're going to use this formula. Now I want to solve for V2. So let's do that together. P1V1 equals P2V2. I want to get V2 by itself, so we just divide both sides by P2. P2 cancels out, and we'll get V2 equals P1V1 divided by P2. Nice. So we've solved for V2. Now we can just plug everything in. Our P1 was the 55 millimeters of mercury. times the V1, 125 mils, divided by the second pressure, 58 millimeters of mercury. I always check units. By the way, that's how I got through physics. Look at your units. They'll always tell you if you set it up correctly. Notice millimeters of mercury cancels, and what am I left with? Mils. Is that a unit for volume? Absolutely. So we set it up correctly. V2 equals. So my calculator, 55 times 125 divided by 78, and our answer is 88 mils. Now, was our prediction correct? We saw that the pressure increased. We predicted that the volume would decrease. It went from 125 to 88. Sure enough, it decreased. Okay, great work. Love gas laws. Boyle's law. Have a really good day. If you need help, look at Gay-Lussac, and also look at, let's see here, the combined gas law, Charles law, if you need help on other gas laws. Thanks so much. Bye.